Hi, in this video we're going to look at the standard operations for directly manipulating binary values in code. Computers operate in binary, but when we write code, we mostly work with data types comprised of many bits. For example, integers are often 32 or 64 bits wide. CPUs provide low-level instructions that give us standard ways to very efficiently manipulate data at a binary level, and higher-level programming languages provide operators for this logic. We call these bitwise operators. And we'll take two values and compare each bit in each corresponding slot, and if there's 1 in both slots, then the result is 1, otherwise it will be 0. So let's say we have two numbers, 5 and 6, or in binary, 0101 and 0110. If we AND them together, we get the result 0100. In the first slot, they're both zeros, so the AND together becomes 0. The second slot is 1 and 1, so that results in 1. In the third slot, however, we have 0 and 1. Now, they're different values, so they result in 0. And again, we have 1 and 0. That also results in 0. Or we'll also compare the bits of two values. But unlike AND, the result is 1 if there's a 1 in either slot. So if we instead OR our numbers together, we get the result 0, 1, 1, 1. Looking at the slots again, we have 0 and 0, so they will also be 0. We have 1 and 1, so that will also be 1. In the next slot, we have 1 and 0. Now one of these values is 1, our slot results in 1. And again, 1 and 0, which will return 1. With exclusive OR, we only get a value of 1 when the slots being compared are different. So looking at the numbers again, XORing 0101 with 0110 results in 0011. The first slot are both 0, so that results in 0 because they're the same. And again, 1 and 1 will also be 0 because they're the same. Now in the third slot we have 0 and 1. That results in 1 because they're different. And also in the fourth slot we have 1 and 0, which also results in 1. The NOT operator will take the value and invert its bits. So if we NOT 0101, we get 1010, the inverse of the original value. Left shift will move the bits of the value to the left by a specified amount. Any bits that exceed the size of the integer are dropped. So if we left shift 0001 by 2, we get 0100. As you may expect, right shift will move the bits of the value to the right by a specified amount, and any values will also fall off to the right. So shifting 0101 to the right by 2 will result in 0001. Shift operations can be an extremely efficient way to multiply or divide powers of 2. Left shifting by 1 will multiply by 2, and right shifting by 1 will divide by 2. So those are all the bitwise operators. And there's nothing stopping us from combining them. For example, we could implement NAND, which is not AND, by ANDing two values and then inverting the result with NOT. So if we want to NAND 0101 and 0110, we end up with 1011 because we AND the numbers to 0100 and then NOT them, which inverts it to 1011. So let's say we have four properties we want to keep track of. If something is bread, if it's a bagel, is it toasted, and is it buttered? To make these flags work, each one needs to be a unique power of 2, which we call a bit mask. Is bread will be 1, is bagel is 2, is toasted is 4, and is buttered is 8. Since these are powers of 2, each bit mask uses the next slot in the binary representation. Now we can create some variables using combinations of these flags by ORing them together. Let's say some toasted bread is bread and is toasted ORed together, resulting in the binary 0101. And in our code, we can check to see if the bread is toasted or not by using AND against the isToasted bit mask. The AND here will compare the variable with the isToasted bit mask, zeroing out any bits in toasted bread which aren't in isToasted. The result in this case will be 0100, since our bread is actually toasted. But if we wanted to know if the bread is a bagel, we would OR it against isBagel, and here the result will be 0, as the bit mask of isBagel isn't in the bits set for toasted bread. So what if the toasted didn't work, and what we really have is just plain bread? Well, we can remove the toasted flag by getting the inverse of toast and using AND against toasted bread. The NOT inverts is toasted from 0, 1, 0, 0 to 1, 0, 1, 1, and by using AND with that value, we ensure that all other bits that have been set before are preserved, but clear the bit that was previously set by is toasted.